Welcome to this next video in this Arduino C++ for Model Railway Control series. Now, in the last video that I did, I was using a stud and probe system via some shift registers to control MOSFETs that in turn triggered solenoid turnout motors. In this video, we're going to continue, this time adding in the LEDs for the control panel so that we actually see a visual indication of the direction. And also we're going to add the ability to control servos at the same time. Now, if you think the cover picture looks like it's a bit of a sort of a bird's nest of wiring, wait till you see the workbench. Let's get started. So as you can see, the workbench is absolutely jam-packed. The UNO is sort of hidden under here. The capacitor discharge unit is at the back. And in the last video, the way that it was working was using the stud and probe system. I could control the solenoids here. Now, obviously this time, as I move them, you can see that I've also added in the LEDs that would be fitted into the control panel. Unfortunately, the LEDs that I wanted are not here yet, so they're mounted on a breadboard. The other bit that I've got on the board today is a couple of servos, because as well as these solenoids, I'm going to include some code today to control the servos. And as you can see, again, the LEDs also show the direction as it changes. Now, instead of a breadboard for the shift registers, I've actually got them mounted on this PCB. This PCB is actually for NOW rails, so it's actually designed for a ESP-32 to go on here, but it works exactly the same circuit, so it's fine for this project today. So let's get started and see how this all comes together. So as always, below the video on YouTube, you'll see the link. Again, the link's on the page here, and this takes us over to the Digital Town site, which will give you the circuit diagrams and the code for today. And while we're thinking of Digital Town, and moving over to the website, don't forget to click the like and subscribe, because it really does help the channel out. Right, let's have a look at the circuit diagram. So coming over to the Digital Town website, if you click on the model railway projects and scroll your way down, you will eventually get to the resources for today's lesson. Now, there is the circuit diagram, there is the code to download, there is also links to lessons 21 and 22 on my Arduino beginners course. That's because the lesson 21 covers the one type of shift register, the shift in register that I'm using for the buttons, and the lesson 22 covers the shift out register that I shall be using for the LEDs. Now, the reason for using shift registers is that the UNO has a limited number of pins, and with model railways we tend to want a lot of buttons and switches and stuff. So there's just not enough on any type of Arduino, so shift registers allow almost limitless numbers to be added. Right, let's have a look at the circuit diagram. Now, the circuit diagram for today's lesson, if you click on it and just download it as a file, it is actually a very large image file, far bigger than I can fit on this video. The reason for doing it so big was to make it easier if you're looking at the video to figure out exactly how the circuit works. So let's break it down into some basics. In the last lesson, I was using the shift registers. These are the CD4021s. Now, I'm only showing 2. Obviously on the boards I've got 4, and you can daisy chain these as many as you want. In fact, that circuit board that I'm using with them mounted on, those boards can be daisy chained, so I can have as many buttons as I want. Now, I'm using a stud and probe system, but it works in exactly the same way as a momentary switch would. These have got the 10K pull down resistors to keep the signals clean, and then you just have the 3 connections that go up to the Uno. All of that was covered in the last lesson and also in those other tutorial lessons if you want to figure out, if you don't know how all of that works. Now, what we were doing in the last lesson was then using MOSFETs with the capacitor discharge unit. Now, the capacitor discharge unit in my case is giving, I think it's 18 to 24 volts DC. 24 volts DC will destroy an Uno and most of these other electronic components. So one of the things to make sure is, although the ground needs to be common with the Arduino Uno, you do not want the 18 volts, 24 volts going anywhere near the Uno. So the only things that get the 24 volts, that is going through the solenoids. They are switched on and off, if you like. The path to ground is switched through these MOSFETs, as was covered in the last video. So this basically comes in through the MOSFET, back to ground and out. It does not go anywhere near the other components. And that is why on my breadboard, I've actually got it written on one of the rails on the breadboard that it is the 24 volt rail, just so that I didn't plug anything in incorrectly and fry my Uno. So that's where I'd got to in the last video. So the new section for this video is these shift out registers. Now these are what are they called here? Long code number 74HC595N. So these are very cheap to buy. I think I'm paying about £3 for 5 or something like that, probably cheaper if I'm buying off AliExpress. Again, I'm only showing 3 on here. You can just keep daisy chaining these on and on. However, there is an issue with these that you need to be aware of. If you start to use lots of these, then they are starting to draw some power, especially when you're powering all these LEDs. Your Uno is not going to be able to provide enough power to power all of this. So I have a separate 5 volt DC supply that is powering these chips. So there is still the ground connection, but the actual 5 volt supply is independent. The reason for this, even when I was doing testing on that board with the ESP-32, once I'd got sort of 4 chips up and running, I started to notice some weird issues on the 4th chip. And that was definitely down to power. Thankfully, I'd put a separate power supply in, so it wasn't a problem to add the extra power in. But it's just something to be aware of if you're using a lot of these chips and a lot of LEDs. You know, you've got all these resistors, all this stuff. It's going to take more than your Uno can supply. The Uno doesn't seem to have any problem with the shift in registers, because it's only a little digital signal. It's not actually powering anything. At the same time, I've also got this 5 volt supply going down to these PCA 9685 boards. Now I'm only using one board today because, you know, space is limited, but again, you can daisy chain as many of these as you want. And obviously with the ability to add 16 servos per board, you can see that using very few pins, you can actually start to control a whole load of solenoids or servos as you require, because these boards only require 2 connections to the Uno. The shift outs for the LEDs, once again, only use 3 connections, and the buttons are only using 3 connections. In fact, the only thing that uses a lot of connections is for the MOSFETs. So that's the circuit board. Now I'm going to show you how I changed the code from the last version to the latest version. So going back to the circuit, the main change is on my last version, I was only using 2 of these input shift registers. Obviously this board has got 4, so the first thing I needed to do was make sure that the code was changed ready to accept those extra chips. So going over to the Arduino IDE, basically what I did was I took version 5 of the CD4021 control panel code, renamed it to version 6, and then coming down here I altered the code so that it was now using 4 chips. Now you'd sort of think, well, it's only a simple change, why only make that single modification and have a whole new version? Well, for me, the reason was that I was using it on a completely different circuit and I wanted to make sure that everything was working correctly. So just a quick whiz through the code. I've written some functions for using these chips, so I'm not going to go into all the details of that. The connection pins for the shift registers, this is the stud and probe system, or you can swap that for momentary switches. I'm using pins 7, 8 and 9, and there is a micro delay of 30 milliseconds that is required for the way that the chips work. Although it says num relays in the code, and I've got the code set to 4, you can use MOSFETs or relays depending on what you want to do, as I showed you in the last video. The rest of it is basically the same. I fired it all up, and the big check for me was then just to see that everything worked. Now, as we come down into the main loop, we've got 2 basic functions. One is unset relay, or it also unsets the MOSFET as required. So what this does is, after a very short period of time, and the delay I have set is 150 milliseconds for the MOSFETs. So after 150 milliseconds in the main loop, it will look at this function. It'll go, hey, it's time to unset the MOSFET that was just triggered. So it will turn off the power to the solenoid and stop the solenoid from getting burnt out. The other function that's called is this one that checks the CD4021 chips for any changes. Now this function is the function where, if you like, you have to do your editing of your code depending how many buttons or switches you have. So this is basically checking the inputs to see if anything's changed, and the bit that you have to work on is the switch statement. So I am triggering the relay. So if it's button 15, then if that has a value that is greater than 0, so the pin has been touched, it's gone high, then it calls this function, trigger the relay, and that sets that, in my case, the MOSFET goes high momentarily, the same going down through these other ones. So that was my code, and if I upload it, so now as I start to touch the probes, my MOSFETs are firing, so the solenoids are moving, and you can also see in the bottom left corner of the screen, as I touch the buttons, you will see the number appear. Now you'll see the number appear twice because it appears every time there is a change of state. So that appears when I touch the probe and also when I untouch the probe. So you get this sort of double value. Now that is why in the switch statement I only trigger the solenoid when the pin goes high. But as you can see, all that code's running. So at this point I now knew that the mods I'd made to the code and the board that I'd connected to were all working correctly. So we now come to sketch 7. As you can see, this is based on version 6, and I put a note on that the MOSFETs had all triggered correctly. And what we're adding in now is the LEDs on the 74HC595N chips. So bringing in my circuit diagram, the bit that we're now adding in is this part of the circuit, And if we zoom in, let's see if this will work. He says, hopefully. As you can see, as we zoom in, we are connecting these chips here to pins 10, 11, and 12. So just like with the CD4021 chips, I've already done a lesson on how to use these chips, and I've made some simple to use functions. So all you need to do is create a definition for the number of chips that you're using. In my case, I'm going to be using 4. I then put in my latch pin, clock pin, and data pin. Now again, if you don't know which pins are which, take a look at the circuit diagram, or even better, probably go and have a look at those previous lessons I did, which have the close-ups of the chips and show you exactly which pins are which. We then create an array. There is a byte array that stores all the data that's being sent to the chip. Each chip is sent 1 byte of information, and that byte of information is obviously made up of 8 zeros and ones, which coincides with the fact that it has 8 pins that can turn something on or off. So each byte basically tells the chip which pins to set high or low. I also have a variable here, send state. This lets me know that something has changed in the code. If you like, one of the bytes has been changed and it's time to resend the information. There's no point endlessly sending the information to the chips if it's the same data. I only want to update the chip when a new value has been, if you like, added. So those are the variables that we require for that. Then what I did was, coming down here, I wrote a little bit of code, because again, I'm starting off with a test. I'm going to have a counter, and all I'm going to do is work through all of the outputs of the chips to make sure that all the outputs are working correctly. So although we're going to leave all the control code in for the CD4021 chips, this next sketch just adds in a simple LED flashing bit of code just to make sure everything works. Now, what happens here, if we go down to the main loop, it's using a Millis timer, because obviously this is non-blocking code. We do not want delay in the code. And it's going through values 0 to 31. Once it gets to 31, it goes back to 0 again, because I've only got 32 outputs and they are numbered 0 to 31. And what it does is it sets the LED high and it sets the previous LED low. That's what this last counter equals counter. Every time this runs around a loop, it sort of says, right, which is the last LED that was lit. And it calls this function shift 74HC59 right. Now, the good thing is you don't have to panic about how this function works. I've got it set lower down in the code. Where are we? There we go. And this function deals with updating all the information that needs to be sent to the chip. And also, if I put an invalid number in, it will serial print the fact that that number is an impossible value for the number of chips that I've got. So if I put in a minus number or 64 or something, that's more than my 32 slots that I've got. Going back to the main loop, it says, scrolling all the way up, it's quite a long way. Too far. All that then happens is there is a function here that processes the output chips. This function basically looks, when this function triggers, it sets a flag in the variable that we looked at earlier, send state, and when the loop runs, if this function sees that that send state has changed, then it will send the data to the chips and reset the LEDs. That was all covered in the previous lesson, so I'm not going to go into that in any real detail, but that is basically to set an LED high or low. You just send it the LED number, and the way the numbers work, if I bring over the circuit diagram, the chip nearest to the UNO is chip 0, and so then the LEDs are numbered 0, 1, 2, 3, 4, 5, 6, 7, and then immediately 8, 9, 10, 11, 12, and so on, as you work up for as many chips as you have in the system. Now, once I've uploaded the code, you can see that the different LEDs start to flash. There is a gap between them because I've got them plugged into 3 different chips just because I wanted to test it. But at the same time, while those are flashing, the MOSFETs are still able to trigger. So this, if you like, is testing that the LEDs and the output chips are working while maintaining the code that controls the MOSFETs. Now again, it may seem strange to go through these little steps, but the reason is if I didn't do that test and I started to build the next section, if I hadn't tested all the LEDs, how would I know if I'd got an error or not? In fact, what I can quickly do, if we go back to the camera, let me just show you an error that you can easily get. So if you watch the board, you can see that the LEDs light up in their normal progression. Now what I'm going to do is just pull out this connection here. And this is going to mean that there is not the correct voltage now being applied to the system. Now you notice how the LEDs now go completely bonkers. Now, if I wasn't running that test script, how would I know if I'd got a bad connection or if I'd got bad code? So this is the reason for doing this step by step. It makes sure that I can make sure that the hardware and the software are all working correctly as individual units before putting it all together. So in this next sketch, sketch 8, I've added in obviously the extra pins that we're using, done the chip numbers, and then the big change, obviously I've taken out that timer code, but all that happens is now in this function where we check the CD4021 chips, you remember the switch statement where we were triggering the relay. After that, all I'm then doing is saying if this relay is triggered, or in my case, if the MOSFET is triggered, then I'm going to set LED 0 high and LED 1 low. That's because on my system, if you like, one of these would be the left move, the other would be the right move, and then the opposite side of the solenoid, I've done exactly the opposite. Now, if you had one of these triggers that was triggering 2 solenoids at the same time, obviously you will need to add in more of these lines of code to turn the appropriate LEDs on and off. But all I've basically done now is just added in these lines for each of the MOSFETs as it is triggered, and that will then deal with the LEDs. So let's take a look at the breadboard and see it in action. So now when I start to touch the studs, obviously these could have been momentary switches, but this is cheaper. As you can see, not only does the solenoid fire, but now I have my LEDs moving, and these obviously could have been mounted in the control panel. So if all you're after is controlling solenoids with either MOSFETs or relays, and you want the LEDs and a stud and probe or push to make switches to control your system, At that point, this sketch control panel version 8 will do everything you need. However, I prefer servos, so I've added a sketch 9 that's going to show you how to use the servos as well. Now, going back to the Digital Town website, if you're looking at today's resource, if you just scroll up a little bit, you will find there were lessons on using servos. There's one here with push buttons, one with latching switches. I would look at the switches part 1, the momentary switches, because the code that I'm going to be using for this is based on the version that uses the PCA 9685 board. Now, the reason that I'm using the PCA 9685 board version is quite simple. With these 2 sets of chips, that's 6 pins gone. I've then got 4 pins that are being used up for the MOSFETs. And to fit this in on an Uno, if I just use A4 and A5, which are the SCL and SDA lines for the wire library, using these PCA 9685 boards, I only require 2 connections no matter how many servos I want to fit. So just with these 2 boards shown in the diagram, I could have 32 servos. One thing to be aware of though, you must have the external power supply for these boards, because your Uno is not capable of moving basically more than 1 servo. And with all of this other circuitry, it probably won't even be able to move 1 servo. So make sure that you've got that external power supply, and be aware that servos can use quite a bit of power. So if you look in that old video, you'll see there's a sort of way of working out how many amps you're going to require for your servos. So that's the circuitry for this. Let's now look at the code. So the way the code is written, it's a very, very simple system that uses an array. I'll put a link to another video I did on writing this code as well in the resource page. And basically you tell it how many of the PWM 9685 boards you're using. So in my case, I'm only using 1. I've also got a servo step size. This is to do with the, if you like, how fine a movement you want the servo to make. If you set this really small there and you've got a lot of servos, you can run into some issues, as you'll see on the previous video. This value here you don't need to touch unless you really know what it is, and these values here, don't touch them either. This one, we set up the array of the servo driver boards. I've only got 1 item in the array, but by keeping it in the array, it keeps all the functions working nicely. If you wanted to add a second board, all you would do is add in this bit of code. And in this case, we'll say the second board has an address of 41. And obviously you'd need to change that line there. Just making those changes would now make the next 16 servo slots available to you. So I've changed my code back to standard. We then have an array and a set of variables. All these are to do with the movement of the servos, because the way this is written is if I was to touch 2 different probes, it can actually start to move the first servo, and then we'll start moving the second servo at the same time. So the way this is written, there is a speed that is set, so it moves in a lot of little steps. Right, the rest of the code from here down is from the previous sketch. So we'll ignore that bit down to here, and we will now come down to, let's take that out. That was the test code. And we come down to the setup. Now, the bits that have got to be added in the setup, you must put the wire begin. to start the wire library, and then we have this for loop that just sets up the PCA 9685 boards. It sets their frequencies, various other bits and pieces, and basically initializes everything ready to go. This little bit of code here, this little for loop, makes the servos start and finish angle the same. Now this is important. If you miss this out, when the system starts up, it will immediately assume that the servo needs to move to a position of 0. And that can be very nasty if you're moving a point motor, a turnout motor, where you only want it to move, say, 20 or 30 degrees. So this prevents sudden movement outside the range of movement that you want. Again, all that was covered in the previous video. Now, coming down to the actual main loop, the only thing that is added is this servo movement control, and this is just looking around, waiting to see, is it time to move anything? The other line that is added is current micros, because the servo control is in microseconds, not milliseconds, because we want a much finer control for the movement. Now, the way this works, there is a couple of functions that are added into the code to do with the servos. The one right at the bottom is servo movement control. This works out if it's time for a servo to move and deals with it. And then the other bit here is a function called servo set movement. And this is where we send the instruction to our servo on what we want it to do. So we have a board number. So the first one in the array is board 0. Second one, if you're using more than one PCA 9685 board, that would be 1, and so on. Then you've got the servo number. So on the PCA 9685 board, the servo, if you like, closest to the connections. Let's bring the circuit diagram in. So on this setup, this would be board 0, and port 0 is this one here. They are actually numbered, and it's 0 to 15. So going back to our code, we send this function the board, the servo, the destination, that is the angle that we want it to move to, and the duration, that is the time that we want it to take to get there. Now, if you set this down at 0, it's going to try and jump there instantly. I think I've got mine set at about 1.5 seconds for this sketch, but this is the function that is called. And just like earlier, when I was doing the system for the triggering the MOSFETs, so we're in that function called, hang on, where's the name? Check CD4021 chips. So we've got the existing code that is going to control the MOSFETs using pins 12 to 15. I'm then going to use pins 2, 3, 4, and 5 on my control panel, and those are going to set the LED, and then they are going to move the servos. So this one is quite easy. It's going to use the servo. I'm using only one board, so board 0. I've got the first servo is plugged into port 15. I want it to move to an angle of 140 degrees, and I want it to take 1.5 seconds to get there. If stud 3 is pressed, I want it to move to 40 degrees, and again 1.5 seconds. If stud 4 is pressed, I want the servo on port 14 to move, and again, if stud 5 is pressed, I want the same servo, and I want it to move in the other direction. Now again, if you needed 2 servos to move at the same time, you would just basically put some code in. Let's just do an example. You'd stick that in there, and you might also want that LED to change as well. So that will all happen when this particular stud is pressed. Now the code is uploaded. If I just press these two studs here, you can see as I touch them, and I can move them both together. And as I do so, obviously the LEDs are changing to suit. And at the same time, the original MOSFETs are still working. So at this point, I have basically one function that I need to do the editing in. That is this single function check CD4021 chips. And from this function, I can now trigger relays, MOSFETs, the LEDs, and the servos as I wish. So if you want to build a control panel, you can basically use this single sketch to do everything that you need. Now at this point, the project is basically finished. And for a smallish layout, this kind of setup would be fine. The issue that would tend to arise is if you had a really large layout. If you can imagine the wiring that goes from the control panel to the Arduino and then all the way through the layout, that can get really long. And so in an ideal world, it would be nice to have the control panel separated out from another controller that, if you like, was on the board and controlling either the servos or the MOSFETs. Now what I'm going to do is build up this control panel with the ESP32, and then I'm going to show you how the NOW rail system works, because using the NOW rail system, this is going to read the contacts and send the information over wirelessly to the railway, so it drastically reduces my wiring. But there are other methods. We could use serial communication. There are other ways that we could, if you like, reduce the wiring or even allow this to send out DCC signals if needed. So I'm going to finish the video there today. If there's any particular method that you would like to have covered to do with separating, if you like, the control panel from the actuation of the solenoids or servos, let me know. I'm going to do the NOW rail video to show you the wireless method, but if there's other ones you want, if you want to see how to send maybe some DCC signals with, I can do it with DCC-EX. Also, it's possible to do it with the NCE cab bus in quite an easy way. I can always do some videos on those, so let me know in the comments. And also make sure in the comments, just check the website for any updates, because now and again, if I see any issues in the code, I'll put something in the comments to let you know that a modification has been made. Right, that's it basically for this control panel series, and I will now get on with the NOW rail control panel and build it up ready for some videos in the future. Thanks for watching, and again, if there's any bits that you want covering, please let me know in the comments or email me off the Digital Town website. Thanks for watching. See you in the next video. Bye for now.